Okay, this is as a continuation of our topic in binary operation. Now we are going to discuss identity elements. Identity element is simply an element that doesn't affect the result of a binary operation. I want to prove it. Now, under identity elements, especially under addition, it is 0. And under multiplication is going to give us 1. Now, let us prove it with this operation. Okay, recall such that E is being represented as E is representing identity element in such a way that A is an element of a real number. This implies that A operation E will be equal to A operation A, which is A. It did not affect the result. It seems as if there is nothing this E is doing here. All right. Now, we are now going to reflect this identity element in the equation. That is by the definition of the binary operation. We shall now have A operation E. This sign and this sign simply means the same thing, operation, equal to A plus E. Now, here is equation 2, while here is equation 1. We are now going to equate equation 2 to equation 1. We shall now have A plus E equal to A. Making E subject of the formula will give us A minus A, and E will now give us 0. This is the proof of identity under addition. Now let us prove it also under multiplication. Using x, which operation y equal to yx, recall this means such that in mathematics, that x operation E is equal to E operation S, which will give us what? X. And here will now be our equation 1. Then again, we shall now have X operation E. I'm now reflecting this identity in the equation, which will give us what? EX. And here will now be equation 2. Equate equation 2 to equation 1. We will have EX equal to equation 1, which we have here as what? X. And before we can make this E subject of the formula, we have to divide both sides by X. X and then X. X can now cancel X. We now have 1 because any number that is being divided by itself will always draw to 1, whether it is a known variable or an unknown variable. Okay. The number 1 question reads M operation n equal to m plus n plus mn. We should find the identity. Recall such that m operation E is equal to E operation m, which will give us what? M. Now, we are now going to reflect this identity in the equation, and we will have m operation E equal to m plus E plus me. Now is the time to equate equation 2 to equation 1. Here is our equation 2, and here equation 1. And this means m plus E plus me equal to m. Now, this m is going to cross the equality sign. We have E plus me equal to m minus m. And E plus me will now be 0. We want to factor out this E because we want to make E subject of the formula, and this E now happens to be here and here. How do we do it? We will now factorize. We will factorize. Factor E out, we have E bracket 1 plus m. This multiply this will give us this. This multiply this will still give us me, all equal to 0. And for me to make e subject of the formula, I have to divide both sides by the variables we have inside the bracket. 1 plus m all over 1 plus m. E will now be equal to 0 plus 0 divided by this will always be what? 0. Even if we have 0 as the denominator, it is undefined, which all implies 0. Now we have x operation y, which is equal to 4xy plus x plus y. Will now be x operation e equal to e operation x, which will give us x, equation 1. Reflecting it in the equation, we have x operation e equal to 4xe plus x, then plus e, equation 2. Reflect this in this way. We are going to equate equation 2 to 1. We have 4xe plus x plus e equal to x. And we have 4xe plus e equal to x minus x. We are still having this at the both sides. That means we are going to factor e out, and we will have e equal to 4x plus 1 equal to 0. Now, dividing both sides here, we have 4x plus 1 all over 4x plus 1. At this moment, this will cancel out, and our e will be 0 again. Thank you. If you love what you just watched, kindly subscribe. Thank you so much for being on a mad diet at MWW Math Empire, where numbers talk.